Hi everyone, so this is May 2021. It is the MYP Math Extended paper and this is question 1. So we have the elements of the universal set U are 1 through to 10, all integers. Consider two subsets of U. So set A contains the multiples of 2, set B contains the multiples of 3. Okay, so here's our Venn diagram. The first thing we are asked to find for question 1A is determine the probability of A given B prime or given not B. Okay, so in terms of what this looks like, okay, I've already put in the conditional probability formula. Now, just a reminder that this is in your formula booklet. Now, the thing to note here that the difference is that it wants B prime or given that it's not B. Okay, so with regards to your formula, you just basically need to input that dash. Well, let me make my pen a little bit thinner. Okay, so we want not B. Okay, so let's take a look. All right, let's look at our diagram. So probability of A given that it's not B. Okay, so if I was to highlight where it is not B, okay, I would highlight all of this. Okay, so in terms of the number of values that are available to me, I have 1, 2, 3, 4 within A, but I have 7 in total. Okay, so determine the probability of A given that it's not B. So my probability of A and not B, okay, is going to be 4 over probability that it's not B. There is 7 in total. Okay, so 4 over 7 is your answer to question 1A. Okay, so moving on to question B. Two numbers are selected at random from U. Calculate the probability that only one is an element of A intersection B prime. Okay, so there's a couple of different ways to do this, okay? I'm going to almost think about this as like a tree diagram, first pick, second pick, okay? So my first pick, in terms of total elements, there are 10 total elements, so 10 available, okay? So first probability is out of 10, okay? If I was to pick the first time, one element from A and B prime, okay, I would be picking from 4 options out of 10, okay? Once I've taken one of these out, okay, on my second pick, I want it to be not from this, okay? So in terms of what I've got left, well, I've got 6 numbers left that are not from this particular section, and I would only have 9 numbers left to pick from, okay? So our two probabilities, first one is 4 out of 10. We have one less number, 6 that would not be from A intersection B prime. And then I'm just going to multiply my fractions across. So 4 times 6 is 24. 10 times 9, 10 times 9 is 90. Okay, and then we want to simplify really. So let's see, 12 over 45. Divide by 3, so 4 over 15, and that is as simplified as possible. Okay, and then that's it for question 1. Okay, for question 2, we have a completed addition grid. This purely is just to show you how it works, okay? And then we are asked to complete the following one. So write down the values of A, B, and C in a simplified exact form. Okay, so let's start with A. Okay, so I know that A plus log 6 is equal to log 3. Okay, so if I rearrange this by subtracting log 6 from both sides, I would have a is equal to log 3 minus log 6. Should keep it in the same format. Okay, our laws of log, when we subtract, we are dividing. So a is equal to log 3 over 6. So a is equal to log of a half. Like that here. I know these are not the best screenshots, but we will make do. So you can write this as log as a half or log of 0.5, even if you wrote this as minus log 2. That would also be fine. Okay, so then I'll do b here. So for b is equal to log 2 plus log 6. So again, remember your laws of logs. When we're adding, we are multiplying, okay? So b is log of 2 times 6. So b is equal to log of 12. Okay, and then for c, we have log 2 plus log 16. So let me just make my pattern back to normal. Okay, so log 2 is better, plus log 16, and that equals to c. Okay, so this would be log of 2 times 16. So c would be equal to log of 32. Okay, so you can have this. Alternatively, you could have 5 log 2 also, if you want to go one step further and simplify, but you do get the mark for both of them. Okay, so that's part A completed. For part B, okay, so the table below shows an example of a completed multiplication grid. Write down the missing values of A, B, and C in a simplified index form. Okay, so for A, we've got A multiplied by x to the power of a half y is equal to 2y cubed. Okay, so let's have a think. We need a 2 to appear, we need x to disappear, and we need an additional y squared going in there. Okay, so let's divide. A is equal to 2y to the power of 3 divided by x to the power of a half over y. Now, when we simplify this, okay, a is equal, 2 is going to stay there. Now, x to the power of a half on the bottom, I'm going to write this to x to the power of minus a half, okay, so that it can come up to the top. And then y cubed divided by y will leave us with y squared. So in terms of what the mark scheme asks for, you can leave it like that. Equally, you could also actually leave it on the bottom if you prefer. Both of these answers are accepted, so either or. Okay, part B, let's see, so we've got 2x to the power of a half, and we are multiplying by x to the power of a half y. Okay, so remember, when we are multiplying powers, we add them. So 2 times our invisible 1 is 2. Okay, a half plus a half is 1, so 2x. And then y to the power of 1 is just going to remain as is. So 2xy is for part B, and then no space to do C, so let me do that here. So for C is going to be equal to, I see, okay, so we have C multiplied by 2x x to the power of a half, and that is equal to x to the power of a half. Okay, let's divide both sides by 2x to the power of a half. So c would be equal to x to the power of a half divided by 2x to the power of a half. Okay, so what you should notice here, a half minus a half would give us 0. Anything to the power of 0 is 1, so they effectively cancel. We have 1, so our answer is a half. Okay, so that is question 2 complete. Thank you. Okay, a skateboard ramp set is built using functions provided in the diagram below. Okay, so ramp 1, f of x is equal to 4 to the power of x. Platform is represented by h of x equals 2. And then the ramp on the right-hand side is g of x is equal to 3 to the power of 5 minus x. Okay, so, So A is this point here. Okay, we've got B also. Now question A is asking us to determine the value of A. Okay, so A is the point in which f of x meets h of x, which is 2, so at 2. So for the value of A, which is an x value, we know that 4 to the power of x is equal to 2. Okay, so just to explain that a little bit further, at this point, the ramp is going up. This ramp is represented by 4 to the power of x. At the point A, it is where it equals to 2. Okay, so 4 to the power of x is equal to 2. 4 to the power of what gives me 2? Well, x must be a half because it's being square rooted. So a half or 0.5. Okay, so that's A found. For B, you're going to do a very, very similar thing, with the exception of you are using g of x this time. So 3 to the power of 5 minus x is equal to 2. So 3 to the power of 5 minus x equals 2. Okay, so is this a calculator question? I believe so. Yes, it is. Okay, so grab your calculator. You can use logs to solve this. So log base 3 of 2 is going to be equal to 5 minus x. So 5 minus x is going to be equal to 0.63. Okay, 5 minus x is equal to 0.6309. Okay. Obviously we've not finished there. We do need to actually calculate the value of x, which in this case is b. So, bit of rearranging. 5 subtract 0.6309 would give me my x value. So x in this case will be 4.369. Okay, 369. Okay, so I'm just thinking as well for both of those questions, perhaps you want to go back and specify that A is 0.5, and in this case it's B, that is 4.369. Again, if you round, just make sure you round correctly. All of these answers would be accepted. Okay, so moving on, hence determine the length of the platform. Okay, so if we're going from an x value of 0.5, that's where the platform starts, and it's going all the way along to 4.369. we simply need to work out the difference between these two. So 4.369 minus 0.5, and that is going to leave me with 3.869. Again, you can round at this point. I'm just checking the mark scheme for us. Yep, so 3.869 would get you the mark. You could have 3.87 or even 3.9. Okay, so various different answers for us there, just all rounded slightly differently. Okay, so question 4, May 2021. Below is a geometric sequence with first term u1 equals 4 and a common ratio of r. Write down the value of r. So remember that we find r from dividing any two consecutive terms. So I'm going to divide u2 by u1. So in this case, that would be 2 root 2 divided by 4, which is just root 2 over 2. Okay, so that's part A done. I'm just going to make a note of that down here to remind me. So r equals root 2 over 2. Okay, by continuing the pattern, determine the value of n when un equals r. Okay, so we have u1, u2, u3. So u4 can be found by multiplying u3 by root 2 over 2. So u4 would be equal to root 2. u5, we're going to take u4, so root 2, and we're going to multiply by the common ratio again. Okay, so this time, root 2 times root 2 is 2. 2 divided by 2 leaves me with 1. I'm going to keep going because I've still not got my un that is equal to r. So now we have 1 multiplied by my common ratio, and of course in this case this is where we now have the value in our sequence that is equal to the common ratio. Okay, so for this, okay, our n value is equal to 6. Okay, so question 4c, given that u21 is equal to 2k, find the value of k. So un is equal to a multiplied by r to the power of n minus 1 for a geometric sequence. Okay, so in this case we have u21. A is the first term, so 4 multiplied by root 2 over 2 to the power of 21 minus 1. And I put that into my calculator and I get 1 over 256. Okay, so I've not finished there yet. I'm told that that's equal to 2 to the power of k. So let me just come over into this space here. Okay, so I know that 2 to the power of k is equal to 1 over, sorry about that, 1 over 256. Okay, so you could use a log here. So log base 2 of 1 over 256 is equal to k. You should find that k is equal to -8. Okay. Okay guys, sorry, I forgot to add question 4D onto the previous recording, so here it is. So we want to find the sum to infinity of 4 plus 2 root 2 plus 2 and so on. So write your answer in the form of a plus b root 2. So our sum to infinity formula is there, where a is our first term, r is our common ratio. So our sum is going to be equal to 4 over 1 minus root 2 over 2. Okay, now the thing is here, if you had a scientific calculator, which I know you do on screen, it's great, however it doesn't give you your answers in terms of surds. So it's not that obvious here, but you actually need to rationalize the denominator. Can't have surds on there. So in order to do this, okay, so we've got 4 over 1 minus root 2 over 2. We are going to multiply by 1 plus root 2 over 2, all divided by the same. Okay, so 1 plus root 2 over 2. Hopefully this brings back some memories. So the top is going to multiply out as though it's a single bracket. So we're going to end up with 4 plus, let's see, 4 root 2 over 2, which would be 2 root 2. And then on the bottom, we've effectively got a difference of 2 squares. Okay, so 1 times 1 is 1. Your 1 times root 2 minus 1 times root 2 over 2, those will cancel out. Okay, so then you're just going to be left with the subtraction of the product of root 2 over 2 multiplied by root 2 over 2, which is, let's think about this, it's going to be root 2 times root 2 is root 4, which is 2, divided by 4, which is a half, so minus a half. Okay, so let's further simplify this. We've got 4 plus 2 root 2 divided by a half. Okay, so let's work that out. That is going to leave us with 8 plus 4 root 2 over 1, which we don't need to write. So the answer is 8 plus 4 root 2, which is in the form that it's asking for. Okay, guys, we are back to question 5. So this question, 9 marks, it is a tough question. Yeah, what can I say? Okay, let's just go for it. Okay, so show that r is equal to 2.8 centimeters, correct to 3 significant figures. Okay, so we have our diagram of the snow cone. What the triangle inside of the sphere here shows us is the radius, and sorry, what we actually have is an isosceles triangle, so hopefully you would be able to spot that. Okay, we're trying to show that the radius is 2.8, so I need to do something here. It is going to be right angled trig. You want to split your triangle in half ultimately. You've got 2 of the same triangles. Make it a right angle, so we can do right angled trig. So we have r here. Our base would now be 2.7. Our angle at the top here is going to be half of that 150, so 75. Okay, so let's think about the sides we've got. Well, we've got the opposite. We've also got the hypotenuse. Okay, so ka, toa. For this question, we've got opposite, got the hypotenuse, 2 ticks with sine, so we are using sine. So sine of theta is equal to the opposite over the hypotenuse. Let's fill in what we know. Well, we know that our angle is 75, our opposite is 2.7, and h is our radius. Okay, so to rearrange this, radius would be equal to 2.7 over sine 75. Let's pop that into our calculator, and we would be getting r is equal to 2.795. Here you just need to make sure that you write enough digits to show that when correctly rounding this to 3 significant figures, we do get 2.8. So just make sure you write r is equal to 2.795, thus r is equal to 2.8. Okay, moving on. So I'm going to come straight down to 5b, and I want to find the value of h. Okay, so I suppose what you need to note here is that the whole sphere of ice melted in the cone as shown in the diagram below. And that is kind of your clue that the previous information is going to come into play in some way. Okay, so what did I know? I know that R is 2.8. Okay, and before this sphere of ice had melted, we had a certain volume, didn't we? Okay, now we want to find the value of H in this question, so I'm just going to draw a new version of this, taking out the right angle triangle shape that I can take from my cone. So just to make it clearer how that would look, it would be this shape here. Now the angle at the bottom is 30. Okay, so I know the angle of this would be 15. It's going to be a right angle. I therefore know that this angle here would be 75. Okay, I'm trying to find this height here. Okay, and we have our radius, which is a capital R in this question. Now the reason they've done this is just so that you don't get confused with the previous question and use the same radius. Now currently we don't have much to go off in this, so I am going to have to use something from the previous question to help me. I'm trying to find the value of H. So the first thing I want to do is think about, well, how could I at least express H in some way? Okay, so volume of a cone is equal to 1/3 pi r squared H. Okay, so that's why we need H, because it's to do with the volume. Okay, we also need our radius. Now, what I know about the volume of this water is that it's going to be the same as the volume of ice previously. Now, I suppose if we go into the science, maybe that, I don't know how true that would be, but ultimately you are going to assume that in this question. Okay, so volume of a cone, we need to know what H is, and we have a volume of a sphere. Oops, can't spell. Is 4/3 pi r cubed. Okay, if I calculate the volume of the sphere using the previous radius, okay, so just by substituting 2.8 in as my value of r, okay, so just pop that into your calculator. 4/3 pi 2.8 cubed, we got 91.95. Okay, so I got a little bit sidetracked there. Let me come back to the volume of the cone now. So 1/3 pi r squared H. Okay, well, let's think about what I know. Well, okay, let's look at some of the angles. So I've got 15 degrees as one of my angles. So if I want to use trigonometry with both my H and R sides involved, if I'm using 15, I have my opposite and I have my adjacent. So tan 15 is equal to R over H. So let's just rearrange that to isolate both, so we've got the options. So H would be equal to R over tan 15. We just switch those out. Equally, R would be equal to tan 15 times by H. Okay, so let's think about this. Let's start to substitute into our volume of a cone. So we've got 1/3 pi. Now R squared, I'm just gonna leave as is for now. Now I'm putting a capital just to remind me that I'm using this radius here and not the one from previously. Okay, and then I'm going to substitute in this here. So instead of writing h, because I don't want two variables that are unknown, I'm going to substitute in that we're timesing by r over 10, 15. Okay, so if I do a little bit of simplification here, what I actually have is pi times r cubed all divided by 3 tan 15. So times tan 15, okay? I know that volume is equal to the volume of the sphere, which was 91.95. 91.95. So now what we need to do is just rearrange to find r. So let's see, we're going to bring the 3. So we're going to have 91.95. We're going to multiply by 3 times tan 15. Okay, that would be equal to pi times r cubed. So let's just go ahead and divide all of that by pi to isolate r cubed. Okay, so r cubed is equal to 91.95 times 3 times 1015 divided by pi. Okay, so r cubed is equal to 23.527. Let's find the cube root of that. So, oops, so annoying. Okay, r is equal to 2.86544. Now, when you're doing this in your calculator, do make sure that you keep all of the values in your calculation. Okay, I'm just going to come down actually onto the next page where I've got a little bit more room. Let's just duplicate this. Okay, let's duplicate these as well. Okay, right, so I've got my r value. My overall object is to find the value of h. Okay, I do have a equation over here that I can use now, and I'm going to substitute r in to find h. So h is equal to this r value we just found. Oops. So 2.86544 divided by tan 15. Okay, so h is equal to 10.6939. If we round that off, h is equal to 10.69 centimeters. Okay, and there we have it. That is a tough one. Okay, so we are on to question 6, which is 15 marks. What we have here is a graph, a cosine curve modeling the body temperature for Ingrid. B is the temperature in degrees Celsius. T is the time in hours after midnight. So do take a note of that. It's after midnight. That means at 0, it is midnight. Okay, so for question 6a, we are told Ingrid knows it is best to sleep for 8 to 10 hours when her body temperature is below, is 36.5 degrees C or below. Okay, so let me just take a look at my graph and identify where she can be asleep. Okay, so it's going to be in this region here and this region here. Okay, so first question wants us to suggest a sleep schedule. We need 8 to 10 hours where we are falling below 36.5 degrees. Okay, so because this is time after midnight, okay, so I can see here at this point, which is one of the minimums, just move that a little bit. Okay, so this is 24 hours after midnight. So this is 12 a.m. again. Okay, so I'm just going to populate these times here just to make it a little bit clearer, okay? So this would be 2 a.m., 4 a.m., 6 a.m. And then working backwards, we would have 10 p.m., 8 p.m., and 6 p.m. Okay, so anywhere in the region of 6 p.m. to 6 a.m., she can have this sleep. Now, obviously, there's not many people, is there, that go to bed at 6 p.m., but it does say that she needs 8 to 10 hours of sleep, okay? So you must make sure that you are within that as well. So I'm going to pick a bedtime of 8 p.m., okay? And she's going to sleep for 8 hours, okay? So that would take me 2, 4, 6, 8. So that would be until 4 a.m. Okay, so there is more than one answer to this question. Okay, so for 6a, suggest a sleeping schedule. Sleep time is going to be 8 p.m. So 8 p.m. And she's going to sleep until 4 a.m. Okay, 8 till 4, that gives me 8 hours sleep. So it's within those ranges, and her body temperature is below the 36.5 degrees. Okay, so 6b, write down the time when Ingrid's body temperature is at a maximum and a minimum. So let's go back to our graph. So we're looking for the highest point and we're looking for the lowest point. Okay, so the highest point, let's see, it's going to be here, isn't it? At 12. So 12 hours after midnight. So 12 p.m. would be the maximum. So 12 p.m. And then the minimum is actually going to be both at 0, so at midnight for both. Okay, so 12 a.m. Okay, you would just drop down here and here to select the correct time. Okay, moving on. Let's just skip that one. Oh, there you go. You can see it better there, that it's AM or PM. Right, so to 6C. During the day, Ingrid's body temperature, B, can be modelled using the equation where T is the time in hours after 12 a.m. Angles are in radians. Question 6C, write down the amplitude and the period. Okay, so the amplitude is the value before cos. Okay, so in this instance, it is 0.5. And then for the period, okay, so if I just go back to the graph, it's easier to explain looking at the graph, okay? So if I pick this point here, so at midnight, that is my start point, okay? One period is one full cycle. So once it gets back to this point, that is a full period, okay? So I know that it gets back to that point at midnight, okay? So after 24 hours. So the period for this cosine graph is 24, okay? 24. Okay, so question 60. Determine the values of the maximum and minimum temperatures. Okay, so here, what you would want to do, I guess, probably easiest to think about our cosine graph itself. Okay, so yeah, I'm guessing that the graphing calculator would be allowed on this and you could just graph it. But just to explain to you, cosine graph usually looks like this. It's not the best drawing, okay? But it's goes up to 1, it goes down to -1, okay? So if I look at my y-intercept here, okay, so 36.5 is where the cosine graph starts in our case, and it's going to fluctuate either side of that by 0.5, okay, because we have 0.5 times 1, okay? So if I add 0.5, I would get my maximum of 37. If I subtract 0.5, my minimum is going to be 36, okay? Again, this would be clearer on a graph, okay? So yeah, I'm guessing it would be allowed for a question like this, so don't worry too much, okay? On to question 6e. So calculate Ingrid's body temperature at 7:15 a.m. to the nearest 1 decimal place. Okay, so all we've got to do here is substitute our time in. However, what we need to realize is that the time that is substituted into the equation here for t is the time in hours after 12 a.m. Okay, so I can't put 7.15 into this, it wouldn't be correct, okay? I have to recognize that 15 minutes of an hour is a quarter. Subbing in 7.25 into my equation, okay? So B is equal to minus 0.5 cos pi over 12, so make sure your calculator is in radians, times 7.25 plus 36.5. Okay, your B answer, let's just pop that in. Okay, you should be getting 36.66. Now it does say in this question to the nearest 1 decimal place, okay, so you have to round this, okay, to 36.7 degrees. Okay, so that is question 6e done with. Right, moving on. So we have Ray's body temperature is 0.25 degrees C higher than Ingrid's. The graph below shows 2 cosine curves modeling the body temperatures for Ingrid and Ray. So this is just a graph transformation. Okay, so it's being moved, it's a vertical shift upwards on the y-axis, and the vertical shift is the 0.25, okay? So if you think of your graph and your y-intercept, okay? So for Ingrid's, the y-intercept's 36.5. So for Ray's, you're going to have the exact same graph, but your y-intercept value is going to increase by 0.25, so 36.75. Okay, I think it asks me this. Yeah, so you would have B is equal to minus 0.5 cos, what was it, pi over 12 t plus 36.75. Okay, and then hence calculate the first time when Ray's body temperature will reach 36.5 degrees. Okay, so we want to set that equation that we just found equal to 36.5. So 36.5 is equal to negative 0.5 cos pi over 12t plus 36.75. So I'm going to subtract the 36.75 from both sides first. Okay, so minus 6.75 minus 36.75. Wow, why did I write 37.75? 36.75. Okay. So now I have minus 0.25 is equal to minus 0.5 times cosine pi over 12t. Okay, so we're going to divide both sides by negative 0.5. Okay, so what we are left with now is half is equal to cos pi over 12t. Okay, so we're going to do inverse cosine to find what effectively the angle is. Now you must remember here that this is in radians, okay? So you need to just make sure your calculator is set to radians. Okay, so inverse cos of a half is going to equal pi over 12t. So okay, so we should be getting, pi over 12t is equal to 1.04, oh, why is it changed? 1.047 and so on. We're going to divide both sides by pi over 12. Okay, so you should be getting that t is equal to 4, so therefore 4 hours. Okay, so no, sorry, yeah, 4 hours, so it would be 4 a.m. because it starts at midnight. Okay, that's it, perfect. Okay, we are up to question 7 on the May 2021 paper. So this question is all about sprinters, their sleeping habits, and their reaction times. Okay, so we have a table here, which is reaction time in seconds, and the number of sprinters. Okay, question 7a is asking us for the mode and the median reaction times. So our mode is going to be the most popular. Okay, so I can look at my table, which has the most sprinters in. Well, it's going to be 0.78. So 0.78 would be our mode, and then our median is our middle value. Okay, so remember, you effectively put them all in order and find the middle. Now they are already in order for us here. So let's look at how many sprinters we have all together. We've got 20. Now, if we were to split these sprinters into 2 equal groups, we would have 10 sprinters in each group. So we're actually looking for the 10.5th piece of information and where that is, okay? So moving along my table in this direction, I've got 4 here, plus 3 would be 7, and then plus 5 is going to take me to 12. So I know my 10.5th piece of information is going to be in this group. So 0.77 seconds for my median. Okay, now I need to show that the mean reaction time is 0.77 for this group of sprinters. Okay, so you want to think of this almost like finding the mean from a frequency table. It's just set out a little bit different. Okay, so we're going to have to do 4 times 0.75. Okay, there's 4 people in that category. We're going to add 3 times 0.76. We're going to add 5 times 0.77. Then we're going to add 6 times 0.78. We're going to add 1 times 0.79 and 1 times 0.78. So add 0.79, add 0.8. Okay, we're going to total that up and divide by 20. Okay, so you're going to get a total of 15.4. But then, of course, we need to divide this by 20 for the 20 runners. So 15.4 divided by 20, and that gives me 0.77 seconds. Okay, moving on. Okay, so groups of sprinters with different sleeping habits take the same task. The graph below shows the mean reaction time of each group. So we've got 8 hours, 7 hours, 6 and 5. Okay, we want to draw a line of best fit here. Okay, so few ways to do this. You want an even number of points either side of the line whilst going through as many points as possible. It may take you a couple of attempts, especially using, the interactive software, although it probably should be slightly easier. Okay, so let's have a look. Okay, so that would be 3 below, 3 above. Okay, so let's see. So that would be that's 2 above, 2 below. Just trying to see if we can get it any more accurate, and just of course make sure that your line goes all the way to the edge of the graph. So let's change that. Let's see. So that's 3 above. Yeah, I'm gonna say about that. Okay. Right, let's see. So using your line of best fit from C, write down the value of R for H equals 4 hours and H equals 7 hours. Okay, so 4 hours, this is why we have to carry on our lines. Probably didn't actually carry it on enough there. But what am I looking at here? 1 point. So we had scale, isn't it? So that would be about 1.16. And then for 7.5 hours, .87. Okay, let's have a look and check our marks here. Do not accept pages. Okay. Okay, so just to give you a little bit more context around the mark scheme here. So they first of all want to make sure that both of those points are on your line. So if I just go back to the accuracy of this, I have to make sure it's continued to the edge, okay? And then they're just looking that you have managed to read off the scale, and they give you can be in plus or minus 0.02 of where it reads off. So if you get the scale a little bit wrong, you've got a tiny bit of leeway, but not much, okay? Right, continuing. Let's see, did I miss anything then? Nope. Okay, so 7E is 3 marks. So we have W is equal to 24 lots of 100 to the power of minus R, where W is the probability of winning a race and R is the mean reaction time in seconds. So calculate the value of W when R is equal to 0.77 seconds. Give your answer correct to two significant figures. So here we want to see that W is equal to 24 lots of 100 to the power of minus 0.77. Okay, this is a calculator question. So you're just going to substitute all of that into your calculator. W is equal to 0.69216, and we want two significant figures, so that is where your final mark is coming from. So 0.69 should be your final answer. Okay, and then on to 7F. Okay, so explore the probability of winning a race for sprinters with different sleeping habits. In your answer, you must identify the two relevant factors affecting the probability of winning, calculate the probability of winning for sprinters with different sleeping habits, comment on the relationship between the probability of winning and sleeping habits, justify the accuracy of your findings. Okay, so W is equal to 24. Yep, we've seen that. So where W is the probability of winning a race, R is the mean reaction time in seconds. Okay, so you want to fill this table in with your with the data that you found. Okay, so I'm just going to go back up to my question here. So I had 1.16 and 0.87. So 1.16 and 0.87. Okay, and then I need to calculate my probability of winning. Okay, so let's just see where, okay, probably going to struggle to fit this on, but that's okay. So I'm just going to substitute those values into my calculator. Okay, we're going to have 1 minus 1.16. Gives me 0.1, we'll call it 1, because we rounded to 2 decimal places before. What was it previously? It was 0.69. Oops. What was that one for actually? That was for minus. Oh, okay, that's not. Yeah, it is on here. What's that again? 69. Okay. And then I'm going to substitute our 0.87 in as well. So 24 to 100 to the power of minus 0.87. Okay, 0.44 rounded to 2 decimal places. Okay, so that would be part of your answer. Okay, you do want to keep referring back to these things that it wants you to do. So identify the two relevant factors affecting the probability of winning. Okay, so the two relevant factors. Affecting or affecting. Okay, reaction time and sleep time. Okay, so that would also get you part of your marks. Okay, what else do we need to look at? So calculate, okay, we've done that. Comment on the relationship between the probability of winning and sleeping habits. Okay, so you want to look here carefully in your table at what have you found. Okay, so the probability of winning, is lowest when sleep time is the lowest as reaction time on average is highest. Okay, you want to say the opposite of this. So the probability of winning is the highest when sleep time is highest and reaction time is quickest. Okay, what else can we say? What else does it want? Justify the accuracy of your findings. Okay, interesting. So, what else do we want to say? Okay, so we want to say things like, you know, the rounding that we've used, why we've used it. Okay, I would say in this scenario, the rounding to 2 decimal places hasn't caused any data to be obscured in any way. Like there's clear differences between the data. What else could we say? Okay, you could comment on the fact that so there's going to be an optimal amount of sleep. Okay, so what I mean by that is if we in fact, let's go back to our graph. Okay, if you look at the graph here, you see the pattern of the graph, it starts to even out. Okay, so it's more like this, isn't it? And that's because you probably all know yourselves, like if you sleep too long, you actually feel quite sluggish and groggy. So there's only so much sleep that will improve reaction time, and then you will just it can go no further. Okay, so what you could do here is substitute some more values in. So you could use your 10 hours of sleep, you could use your 11 hours of sleep point as well, even 9 for that example, and show the data for that and start to say how, you know, it starts to level out. Okay, and that winning does also depend on other factors. You know, you could have, for example, like Usain Bolt, no matter how little sleep he has, he is still going to beat me in a race for sprinters. Okay, it's still going to beat me, doesn't matter, because there's lots of other factors: training, experience, fitness, just talent itself. Okay, and then for this last point, okay, just going back to this and justifying your accuracy. Okay, you want to talk about like accurate since numbers I used in my calculations are rounded to significant figures. But you just basically, to get this mark, you have to say something about the rounding that you've used. You could also talk about the fact that your line of best fit obviously presents some inaccuracies, and actually if you were to do this properly, you would need to use a computer to draw it perfectly so that you could get some better results from it. So all of those sorts of things need to be said here. I've just got no room to do it, I'm sorry, but definitely add like another, they tend to leave a blank column for a reason. Okay, it's a little bit of a clue. All right. Oops, let's try again. Okay, guys, so we are on to question 8, the final question. It is the investigation. So here we have the parabola y equals 2x squared is shown in the graph. Different size rhombuses are drawn inside of the parabola. Drag the slider to see how the rhombuses are formed. So here's an example of stage 1. Then we have stage 4, as seen here. Okay, so 8A, write down the missing values in the table. So you just need to find the pattern. Okay, so look how you get from one to the next. So add 12, add 20, add 28, okay, and then what you should notice here is that these are increasing by 8 each time. Okay, so the next one, we're going to be adding 36, so it would give me 100, and then I want to add 44, thus giving me 144. Okay, so describe in words, so in words, 2 patterns for V. So you could say the difference between the vertical lengths increases by an additional 8 each time. Therefore, what you need to note here is that that is the clue that this is a quadratic sequence. So quadratic sequence would give you your second mark, okay? Moving on, write down a general rule for V in terms of N. Okay, so you need this to be V equals something to do with N. Okay, so let's look at our N values and how we get across here. Now, I just said that this is a quadratic sequence, so I am going to write this out slightly different. So 4, 16, 36, 64. Okay, so as we said before, this is going up, what did I put? So 12, 20, so plus 12, plus 20, plus 28. Okay, and then we do our second difference, which is plus 8, plus 8. So then in terms of your quadratic sequence, you know it's squared. You have to half this value. Okay, so it's going to be something to do with 4n squared. So let's just substitute a few values in to check that we don't need to do anything additionally. So for stage 1, where n is 1, 4 lots of 1 squared would give me 4, which is the vertical length, so that works. For stage 2, where n is 2, 4 times 2 squared is 4, 4 times 4 is 16, so that works. And then if you check for both 3 and 4, you'll see that it also works for those. Okay, then it's asking us to write down, nope, we've done that, sorry. Let me just fill in those other values here, one that I've already found. So here, 100, 144. Okay, verify your general rule for V. Okay, so actually, that's why I was just talking through there. So this for part B, for C, you're gonna, where's question C? That is C. For D, you're going to verify, so you're going to substitute the numbers in. So V of n is equal to 4n squared. So V of 1 equals 4 lots of 1 squared, which is 4. V of 2 is equal to 4 lots of 2 squared, which is 4 times 4, which is 16. V of 3. So when you're verifying, you're using the values that were given to you. Okay? So the values from the table, 9 equals 36, V of 4 equals 4 lots of 4 squared, 4 times 16, which equals 64. Okay, so you can see that all of those are right. Okay, because we're not asked to test at this point, we don't need to use the 5 and 6 or any further information. Okay, that is 3 marks, so make sure you do it 3 times in terms of your verification process. And then we are on to this. Let me just add a page for a bit of working space here. Okay, so investigate the values in the table to find a relationship for the area of the rhombus in terms of n. In your answer, you should predict more values and record these in the table. Describe in words one pattern for A, determine a general rule for A in terms of n, test your general rule, verify, justify, ensure that you communicate all your work inappropriately. Okay, so let's first of all complete the table. Okay, so I already know that 100 is here and 144 is here. Okay, then for H, we are going up by 2 each time. So again, just following the patterns. Okay, now this next one is probably slightly harder to spot. Okay, so obviously when you are finding the area of something, of a shape, you tend to use either the lengths that you have or the heights that you have. Something that a nice way to start with something like this is, well, let's like multiply together. Okay, and what would we get? Okay, so I'm just going to do that in another color just while I investigate this. So 4 times 2 would give me 8, 16 times 4 would give me 64, 36 multiplied by 6, well, that would give me 216, 64 multiplied by 8 would give me 512, 10 times 100, 1,000, 12 times 144. So let's think, we would have plus 288, 8, 12, 6, 7. Okay, 1728. Okay, right. Now what I want to do is I'm going to look at these compared to these. Now I can straight away see the pattern that these are being halved. Okay, so divided by 2, and that consistently works for all. Okay, so in terms of coming up with a rule, so actually hold on, describing words, one pattern for A. Okay, so describing words first. Actually no, sorry, reverse. We'll do the first bullet point first and we'll complete the table. So I think I've found what I need to do to finish the area of the rhombus. So I'm going to write 500 here, okay, which is half of 1,000. I'm then going to work out what half of 1,728 is. Okay, so I'm gonna have, say, 864. Okay, right, so that is part 1 done. Describe in words one pattern for A. So to find A, you multiply vertical length by horizontal length and divide by 2. Okay, so that would be one pattern for A. Determine a general rule for A in terms of N. Okay, so currently what I have is that A is equal to a half times V times H, okay? Now I want to give all of this in terms of N. Now I've already considered what V is in my previous question. V was equal to 4N squared. So I can replace V here with this, okay? So that's the first thing to do. So A is equal to a half times 4N squared times H. So what I need to do is come up with a rule for H in terms of N, okay? So going back to my table, let me use a different color. I am comparing these values here to my N values, okay? So hopefully you would quickly notice that H is simply 2N, okay? So for N is 1, H is 2. For N is 2, H is 4, and so on. So H can be notated as 2N. Okay, so again, like I just did, I'm going to substitute that in for H. Okay, so we have A is equal to a half times 4N squared times 2N. Now this is all in terms of n. So let's just go ahead and simplify, make it look nicer. So a half times, what would that be, 8n cubed. A half of 8n cubed leaves me with 4n cubed. Okay, so that's my area in terms of n for the rhombus. Okay, so let's see what we've done. Right, now we need to test your rule for A, verify and justify, and then communicate. Okay, so what you're going to do at this point is you're going to use this formula and basically show for all of those values that you obtain the correct answer. Okay, so we'll notate it as, okay, so to verify, okay, so in terms of the ones that were given for you, the first 4 were given. So we're going to do A equals 4n cubed. Okay, so that's my notation for the volume. So A of 1, 4 lots of 1 cubed, which equals 4. Compare that to your table. Yep, that works. Okay, A of 2, so 4 lots of 2 cubed, which is 4 times 8, so 32. Okay, A of 3, 4 lots of 3 cubed, so 4 times 27, which is 108. Again, it's in my table. A of 4, so 4 lots of 4 cubed, so 4 lots of 64, which is 2, 5, 6. Yep, correct. Okay, so you can say at this point, hence my rule for area of rhombus is verified. Okay, and then to test, to further test and justify, okay, you want to bring in those 2 additional values, okay? So the 2 additional values would be for 5 and 6 that you should have predicted. So let me just yeah, okay, so to justify, okay, we are going to do A of 5, so 4 lots of 5 cubed, which is 4 times 125, which is 500. Okay, you want A of 6, which is 4 lots of 6 cubed, which is going to give me, let's think about this, 6 times 6 times 6 times 4. Yep, 216 times 4 is 864, and that is what I predicted this to be. So let's see. At this point, you just want to put something along the lines of hence my rule is justified and is correct for finding the area of a rhombus. Okay, and then let's see, so we've done that, ensure that you communicate all your working appropriately. So really you just need to make sure that you show everything that I've shown. It is complex. It's complex to set it out in a very sort of logical, structured way, but ultimately you can always tidy this up at the end once it's done, okay? But yeah, I hope that helps. Do come see me if you need anything else.